In this video, I'm going to teach you some basic things in algebra. So one of the first things that you want to know how to do is you want to be able to add and subtract like terms. So let's go ahead and begin. Let's say if we wish to add 3x plus 5 plus 4x minus 2. So we're adding two binomials. A monomial is simply one term. So 3x is a monomial, 5 is a monomial. But put it together, like 3x plus 5, it becomes a binomial. 4x minus 2, that's a binomial. X squared plus 3x minus 8, that's three terms, so that's a trinomial. 3 is for tri. So how can we add 3x plus 5 and 4x minus 2? How can we do that? The first thing we need to do is add like terms. 3x and 4x are like terms. But what you need to do is add the 3 and the 4. 3 plus 4 is 7, so this is going to give us 7x. And then we could add 5 and negative 2. 5 plus negative 2, or 5 minus 2, that's 3. So the answer is 7x plus 3. Now let's talk about adding two trinomials. For instance, let's say if we have 4x squared plus 3x plus 9, and let's say we wish to add that to 5x squared plus 7x minus 4. Feel free to pause the video and try this example. So what is the sum of these two trinomials? Well, let's begin by adding like terms. So these two are similar. We can't add 4x squared and 3x together because those are not like terms. On the left you have an x squared term, on the middle you have just an x term. So those are not like terms. But we can add 4x squared and 5x squared because they both contain the x squared variable. So what is 4 plus 5? 4 plus 5 is 9. So this will give us 9x squared. For those of you who want a quick review of addition, here's how you can add using a number line. So if you wish to add 4 to 5, start with 5 and travel 4 units to the right. This will take you to 9. So anytime you need to add, travel to the right on a number line. If you need to subtract, travel to the left. Now let's move on. So the next two like terms that we can combine are 3x and 7x. 3x plus 7x, or 3 plus 7, that's 10, and then just carry over the x. That 0 didn't look like a 0. And now the last two things that we can add are 9 and negative 4. 9 plus negative 4, if we use, let's say, a number line, let's start with 9. So we're subtracting 9 by 4. We need to travel 4 units to the left. And so this will be 8, 7, 6, 5. So 9 minus 4 is positive 5. And therefore, this is our answer. 9x squared plus 10x plus 5. Now what about subtracting two trinomials? So let's say if we have 5x squared minus 6x minus 12, and then minus 7x squared plus 4x minus 13. What do you think we need to do here? So take a minute and try this example. Feel free to pause the video as you work on it. So let's begin by identifying the like terms. So we have 5x squared and negative 7x squared. Actually, before we do that, let's distribute the negative sign. That's actually a better thing to do. Now, the negative sign will be distributed to everything on the right, so all of the signs will change. Here we have an invisible positive sign in front of the 7, so a negative times a positive will give us a negative. And in front of this trinomial, we don't have a negative sign, so we could simply get rid of the parentheses. So right now we have 5x squared minus 6x minus 12. Now to distribute the negative sign, everything will change sign. So the 7x squared, which was positive initially, will now be negative. And the positive 4x will now be negative 4x. But the negative 13 will change to positive 13 because a negative times a negative is a positive. Now let's go ahead and combine like terms. So we can combine 5x squared minus 7x squared. 5 minus 7, that's going to be negative 2. So we're going to have negative 2x squared. Now the next two like terms are negative 6 and negative 4. Negative 6x plus negative 4x. What is the answer? What is negative 6 minus 4? So if we were to start with negative 6 and then subtract it by 4, we would have to travel 4 units to the left. And so this would be negative 7, negative 8, negative 9, negative 10. And so negative 6x minus 4x, which is the same as negative 6x plus negative 4x. So you can read it like this, or you could read it like this, because a negative times a positive is a negative. Either way, it will still give you negative 10x. And finally, the last two that we need to combine are negative 12 and 13. So you can read it as negative 12 plus 13, or if you reverse it, positive 13 minus 12, which I think it's easier to see it that way. 13 minus 12 is 1. So negative 12 plus 13 is positive 1. And so this is our answer, negative 2x squared minus 10x plus 1. Now at this point, what we're going to do is we're going to multiply monomials. So what is x cubed times x to the fourth? What is the answer? When you multiply one monomial by another, let's say with a common base, in this case the base is x, what you need to do is you need to add the exponents. So 3 plus 4 is 7. So the answer is x raised to the 7th power. Now let's understand why that's the case. So what really is x to the third power? X to the third power is basically x times x times x. So what it means is that we're multiplying 3 x variables together. And x is basically x to the first power. So 1 plus 1 plus 1 is really 3. So I'm going to write x cubed as x times x times x. Now x to the fourth power basically means that we're multiplying 4x variables together. So when you combine 3x variables and 4x variables, you get that we have 7x variables that we're multiplying together. 3 plus 4 is 7. And so that's why we get this answer, x to the 7th power. For the sake of learning, let's try some other examples. So let's multiply x to the 5th power times x to the 7th power, and also x to the 8th power times x to the 9th power. So feel free to pause the video and try those two problems. So this is going to be x raised to the 5 plus 7, and then you just got to add those two numbers. 5 plus 7 is 12, and so that is the answer for the first problem, x to the 12th power. Now for the second one, you just got to add 8 and 9. So 8 plus 9 is 17. Thus we get x raised to the 17. Now some of you might be wondering, what is x? X is basically a variable. It has a value of which you do not know at the present. But let's say if you have an equation that says 5 plus x is 8. Now x has a specific value in this equation. So what is x? 5 plus what number is 8? Well, we know that 5 plus 3 is 8. So in that particular equation, x is equal to 3. So x is just a variable that can represent any given number. So when you see x, don't let it confuse you. Just think of it as a number that you don't currently know the value of. Now let's say if we have x raised to the 8th power, and let's divide it by x cubed. So what should we do here? Now in a previous example, we saw that when multiplying two variables together, we need to add the exponents. So in this case, 4 plus 5 is 9. But what about when dividing? In this case, we need to subtract the exponents. So it's going to be the top exponent minus the one in the bottom. So 8 minus 3 is 5. Now let's try another example. X raised to the 5th power divided by x squared. So this is going to be x raised to the 5 minus 2, which is x cubed. To visualize it, imagine if we expand x to the 5th power. We know that it's the multiplication of 5 x variables. X squared is simply x times x. Now we can cancel 2 of the x variables on top and on the bottom of the fraction. And so we're left with 3 x variables at the end, which is equal to x cubed. And so that's why this works. Because if you subtract 5 by 2, you get 3. Now what if the exponent in the denominator of the fraction, what if it's greater than the exponent in the numerator of the fraction? What should we do in this case? If we subtract it, starting from the one on top, it's going to be 4 minus 7. And this will give us a negative number. So what does that mean? This is the same as x to the negative third over 1. And whenever you have a negative exponent, you can take the x variable, move it to the bottom, and by doing that, the negative exponent will now become a positive one. And so the final answer is 1 over x cubed. To see why that's the case, we need to expand the original problem. X to the 4th is x times x times x times x. X to the 7th power is the multiplication of 7 x variables. Now we can cancel 4 at a time, and notice that we have 3 x variables in the bottom of the fraction. So therefore, this is going to be 1 over x cubed. And we could see why that's the case now. So anytime you have a negative exponent, you could move it to the other side of the fraction, making it positive. So if I had 1 over x to the negative 5th power, I could take this exponent, move it to the top, and now it's going to be x to the 5th power. You could write it like that, or you could say over 1. It's the same thing. Now let's try some more examples. So go ahead and work on this problem. X to the 5th power divided by x to the 8th power, and also y to the negative 4th. Go ahead and simplify these problems. So for the first one, we can do simple subtraction. So we have 5 minus 8, which is negative 3. Now we need to get rid of the negative exponent. Typically when you're in an algebra course and you want to simplify the variables, your goal is to get rid of any negative exponents. So the final answer is 1 divided by x cubed. Now for this one, we're going to do the same thing. We're just going to put it in the bottom. So the final answer is 1 divided by y to the 4th. Let me write that better. Here we go. And so that's it for these two examples. As you can see, they're not too difficult. Now let's focus our attention on multiplying monomials. So let's say if we have 3x cubed and we wish to multiply it by 5x to the 6th power. How can we do so? The first thing that we need to do in this case is that we need to multiply the coefficients, the numbers in front of the x variables. So 3 times 5 is 15. Next, we need to multiply the variables. X cubed times x to the 6th power. And we know that we can do this by adding the exponents. So 3 plus 6 is 9. So our answer is simply 15 times x raised to the 9th power. So let's try another example. Let's say if we have 4x squared and we wish to multiply it by 7x cubed. Go ahead and try that problem. So in this case, all you need to do is multiply 4 by 7. 4 times 7 is 28, and then we need to multiply x squared by x cubed. And so 2 plus 3 will give us 5. So our answer is 28x to the 5th power, and that's it. Now let's try a more complicated example. So let's say we have 4x y squared, and we're going to multiply it by 8x squared y cubed. So go ahead and try this problem. Now just like before, we're going to multiply the coefficients together. So this is going to be 8 times 4, which is 32. Next, we're going to multiply like variables together. So we have x times x squared. If you don't see an exponent, it's a 1. So all you need to do is add the exponents. 1 plus 2 is 3. So we're going to have x cubed. And then we need to multiply y squared by y cubed. So we need to add 2 and 3. 2 plus 3 is 5. And so this is our answer. 32 x cubed y to the 5th power. Now let's work on some practice problems. So multiply 5x squared y to the 3rd by 6x cubed y to the 4th. And then try this one. 7 a to the 3rd b to the 4th times 8 a to the 5th b to the 7th power. So the first one, we're going to multiply 5 times 6. 5 times 6 is 30. And then we have x squared times x cubed, so 2 plus 3 is 5. So that's going to be x to the 5th power. And then y cubed times y to the 4th, 3 plus 4 is 7. And so it's y to the 7th power. Now let's do the same for this one. So here we have 7 times 8. That's going to be 56. And then a cubed times a to the 5th power. So 3 plus 5, that's 8. And then b to the 4th times b to the 7th. 4 plus 7 is 11. And there you have it. So we have 56 a to the 8th power, b to the 11th. And this is 30 x to the 5th, y to the 7th. And that's it. Now the video that you're currently watching is the first half of the entire video. If you want to gain access to the second half of the video, you could find it on my Patreon page, if of course you wish to support it. Now I do have some other video content that you may find interesting if you're willing to check out the page. So feel free to take a look at that, and let's get back to algebra. So let's go ahead and work on our next problem. Now let's talk about dividing monomials. So let's say we have 24x to the 9th power times y to the 5th power, and we're going to divide it by 8x cubed y to the 12th power. So let's try that. So the first thing we need to do is divide 24 by 8. 24 divided by 8 is 3. Next, we need to divide x to the 9th power by x cubed. And to do that, we need to subtract the top exponent by the bottom one. So it's going to be 9 minus 3. And we're going to do the same thing for the y variable. To divide these two, we need to subtract the exponents. So it's going to be the top exponent minus the one on the bottom. 9 minus 3 is 6. 5 minus 12 is negative 7. Now, what should we do with a negative exponent? So anytime we have it, the variable that bears that negative exponent, we need to move it to the other side of the fraction. So in this case, we need to move it to the bottom of the fraction. So the final answer is going to be 3x to the 6th power over y to the 7th power. And so this is it. Let's work on a more complicated example, one with 3 variables instead of 2. Because on a typical algebra exam, you're going to see some problems that look like this. So we might as well cover it in this video. So go ahead and take a shot at that problem. Go ahead and try it. So what is 12 divided by 36? Since 36 is larger than 12, all we could do is simplify those two numbers. So if you had to reduce this fraction, what would you do? Now you could break this down. For instance, 36 is 12 times 3. And so what you could do, you could say 12 is basically 12 times 1. You could cancel a 12. And so you'll be left with 1 over 3. Thus, we can reduce 12 over 36 to 1 over 3. So I'm going to keep the 1 on top and the 3 on the bottom. Next, we could divide x to the 5th power by x to the 8th power. So initially, the variable will go on top, and it's going to be 5 minus 8, which is negative 3. Now let's move on to the y variables. Let's divide these two. So it's going to be y, and starting with the top exponent, negative 3, and then minus the bottom exponent, negative 4. Now what is negative 3 minus negative 4? A negative times a negative is a positive. So this is negative 3 plus 4. Negative 3 plus 4 is the same as positive 4 minus 3, so this is going to be positive 1. Now for the last one, z to the 4th divided by z to the negative 8, that's going to be z to the 4 minus negative 8, and we can make this a positive sign. So 4 plus 8 is 12. So we have z to the 12 on top. So initially, after you subtract the top exponent by the bottom exponent, the variable will go on the numerator of the fraction. Now, once you've ID'd any variables with a negative exponent, those are the ones that you're going to move to the bottom. So the final answer for this problem is y to the 1st power, which we could just write it as y, times z to the 12th power over 3x cubed. And so this is the final answer for this problem. Now sometimes you're going to see these problems where you have an exponent raised to another exponent. In a situation like this, what do you think we need to do? What is x cubed raised to the 4th power? Whenever you raise an exponent to another exponent, you need to multiply those two exponents. So this is really 3 times 4, which is 12. And one way to think about it is that this, what you have here, this represents 4x cubes being multiplied to each other. So that's what x cubed raised to the 4th power means. And each x cubed represents the multiplication of 3 x variables. So if you count all of the x variables that you're multiplying, you're going to get a total of 12. And so that's why the final answer is x to the 12th power. Here's some other examples that you could try. X to the 4th power raised to the 6th power, and x cubed raised to the 5th power. So for this one, it's just going to be 4 times 6, which is 24. And for the other one, it's going to be 3 times 5, which is 15. And that's all you got to do for those examples. Now sometimes you might have a number in addition to a variable inside the parentheses. So in this case, what do you do in a situation like this? Well, you still need to multiply the exponents on the inside with the one on the outside. Now, the 2 may appear as if it doesn't have an exponent, but it does. It's a 1. And so what you need to do is you need to multiply 1 times 3, which is 3. So you have 2 to the 3rd power. and then 3 times 3 is 9, so now you have x to the 9th power. Now what is 2 raised to the 3rd power? What is this equal to? 2 to the 3rd power is the multiplication of 3 2's. So it's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So our final answer here is 8 times x raised to the 9th power. Go ahead and try the other example. So first we need to multiply 4 by 1 and then 4 times 2. So this is going to be 3 to the 4th power and then y to the 8th power. 2 times 4 is 8. Now what is 3 to the 4th power? So what is 3 times 3 times 3 times 3? So if you take 2 of the 3's and multiply them together, that will give you 9. And if you multiply the other 2 3's together, that will give you another 9. And 9 times 9 is 81. So the final answer is 81 y to the 8th power. Try this one. Let's say if we have 2 to the 3rd power times, let's say x to the 4th, y to the 5th squared. So the first thing we need to do is multiply every exponent on the inside by 2. So 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Now, our next step is to evaluate 2 to the 6th power. So we have 6 2's that we need to multiply. We already know that 2 times 2 times 2 is 8. And so multiplying these 3 2's will give us 8 as well. So 8 times 8 is 64. Therefore, 2 to the 6th power is 64. So our final answer is 64, x to the 8th, y to the 10th. And that's it. Now, what about this example? Let's say we have 3x squared raised to the 2nd power multiplied by 2x cubed raised to the 3rd power. So this time we're multiplying monomials that are raised to some exponent. So the first thing we should do in this case is distribute the 2 to everything on the inside and do the same with the 3. So 2 times 1 is 2, 2 times 2 is 4, and so right now we have 3 squared times x to the 4th, and 1 times 3 is 3, 3 times 3 is 9. Now 3 squared, that's 3 times 3, which is 9, so we have 9x to the 4th, and 2 to the 3rd power, 2 times 2 times 2, that's 8. Next, we'll need to multiply 9 times 8, which is 72, and then we need to multiply x to the 4th times x to the 9th. So we need to add 4 and 9. So the final answer, which I'll write over here, is 72x to the 13th power. So hopefully at this point, you're seeing how to put all of these individual steps together. Now let's move on to our next problem. Let's say we have 3 squared x cubed y to the 4th power raised to the, let's say, 2nd power times 2 to the 3rd, and then x to the 2nd, y to the 5th raised to the 3rd power. Go ahead and try that. So let's begin with the distribution of this exponent. So first we have 2 times 2, which is 4, multiplying these two. And then we're going to multiply 3 times 2, which is 6. So that's going to give us x to the 6th power. And then 4 times 2 is 8. So it's y to the 8th power. Now let's do the same with the second part of the problem. So first, let's multiply 3 times 3. So 3 times 3 is 9, and then let's multiply 3 by 2. So 3 times 2 is 6, and then 3 times 5, which is 15. Now, 3 to the 4th power, we know it's 81 because we did that already. And 2 to the 9th power, what is that? So let me get rid of what I have here. So 2 to the 9th power is basically 2 to the 3rd times 2 to the 3rd times 2 to the 3rd, which is 8 times 8 times 8. Now, 8 times 8 is 64. But what is 64 times 8? So let's do it the old-fashioned way. So 8 times 4 is 32, so we have to carry over the 3. 8 times 6 is 48 plus 3, that's 51, so it's 512. So 2 to the 9th is 512. Now the next thing we need to do is multiply 81 by 512. At this point, I am going to use a calculator for that. And so you should get 41,472. And now we have x to the 6 times x to the 6, so 6 plus 6 is 12. And then y to the 8th times y to the 15th. 8 plus 15 is 23. And this is the final answer. Now, what if you were to see a problem that looks like this? In parentheses, -7 x squared y cubed raised to the 0 power. What is the answer? Anything raised to the 0 power is 1. So 5 to the 0 is 1. 3 to the 0 is 1. So even if you were to see a huge problem like this, with a lot of variables, but if it's raised to the 0 power, the final answer is simply 1. So keep that in mind. Now, what is the difference between these three problems? Let's say if we have -2 to the 3rd power, and then something similar, but the -2 is inside the parentheses, and here we have 1 on the inside and on the outside. So go ahead and calculate the answer for each of these three examples. So the first example means that we have a single negative sign, but we're multiplying two 3's together. So the final answer is simply -8. Now for the second example, the negative is inside the parentheses, so it's affected by the exponent, which means that we're multiplying 3 -2's. But the end result is the same. A negative times a negative is a positive, but a positive times the third negative is a negative. Now for the last example, we have this negative on the outside, and then we have 3 -2's. So we have a total of 4 negative signs. Whenever you multiply an even number of negative signs, it's going to give you a positive answer. So this one is different. It's +8. Now let's talk about multiplying a monomial by a binomial. So 3x is a single term, it's a monomial. 5x plus 8 contains 2 terms, so that's a binomial. Mono means 1, bi means 2. So what is 3x times 5x plus 8? So sometimes in a typical algebra course, you have to simplify an expression that looks like this. What do? So first we need to multiply. What is 3x times 5x? Well, we know that 3 times 5 is 15. And x times x, this is x to the first power times another x to the first power. So 1 plus 1 is 2. So you get x squared. Next, we have 3x times 8, which is 24, with an x attached to it. So this is the answer for this example. It's 15x squared plus 24x. Now let's try this one. Let's multiply a monomial by a trinomial. So go ahead and work on that example. So here we have 4x times x squared. So this is x to the first power times x squared. 1 plus 2 is 3. So this is going to become 4x cubed. Next, let's multiply 4x times negative 2x. 4 times negative 2 is negative 8. And then x to the first power times x to the first power is x to the second power. And finally, 4x times 3, that's going to be 12x. And so that's it for that problem. Now what about multiplying a binomial by another binomial? So what should we do in this case? In this case, what we can do is something called FOIL. Perhaps you've seen that. And F is for the first, O is for the outer, I is for the inner, L is for the last. But the order in which you do it really doesn't matter. As long as you recognize that when you multiply a binomial by a binomial, initially you should get 4 terms before you add or subtract any like terms. So let's begin by multiplying 2x by 3x. So 2 times 3 is 6. X times x is x squared. Now let's multiply 2x by negative 2. 2x times negative 2 is negative 4x. And then 3 times 3x, that's going to be 9x. And then 3 times negative 2 is negative 6. So now let's go ahead and combine like terms. So these two are like terms. Negative 4x plus 9x, that's 5x. Everything else we can just bring it down. So this is going to be the final answer. 6x squared plus 5x minus 6. Let's try another example. So let's multiply 4x plus 7 by 3x minus 6. So go ahead and pause the video and try that problem. So 4x times 3x, that's going to be 12x squared. And then we have 4x times negative 6, which is negative 24x. And then 7 times 3x, that's positive 21x. And then 7 times negative 6 is negative 42. And then combine like terms. Negative 24x plus 21x, that's going to be negative 3x. And so this is our answer. Now let's multiply a binomial by a trinomial. So let's multiply 3x minus 4 by x squared plus 3x minus 5. So a binomial has 2 terms, a trinomial has 3 terms. So initially, we should have 6 terms before we combine like terms. But I'm going to do this a certain way. So let's multiply 3x by x cubed. So that's going to be 3x cubed. 1 plus 2 is 3. Next, let's multiply 3x by 3x. So 3x times 3x is 9x squared. And then we're going to multiply 3x by negative 5, which is negative 15x. Now, let's move on to the negative 4. Let's multiply negative 4 by x squared. Now, I'm going to put that result under 9x squared because they're like terms. Next, let's multiply negative 4 by 3x, which is negative 12x. And then finally, negative 4 by negative 5, which is positive 20. So notice that I have a total of 6 terms. 3 and 3 gives me 6. So anytime you multiply a binomial by a trinomial, you're going to get 6 terms initially. 2 times 3 is 6. Now here, we can bring down the 3x cubed. Next, we can add these two. So positive 9 plus negative 4, or simply 9 minus 4, that's going to be 5. So we have 5x squared. Now let's combine these two. Negative 15 plus negative 12, that's negative 27. And so this is the answer. 3x cubed plus 5x squared minus 27x plus 20. Now let's multiply a trinomial by another trinomial. So let's say we have x squared plus 3x minus 2, and we're going to multiply that by 2x squared plus 4x minus 5. Go ahead and try that problem. So when multiplying a trinomial by a trinomial, initially you should get 9 terms. 3 times 3 is 9. So let's begin by multiplying x squared by 2x squared. So that's going to be 2x to the 4th power. Next, let's multiply x squared by 4x. So that's going to be 4x to the 3rd power. And then we're going to multiply x squared by negative 5, which will give us negative 5x squared. And then 3x times 2x squared, that's going to be 6x cubed. And then 3x times 4x, that's positive 12x squared. And then we have 3x times negative 5, which is negative 15x. Next, we have negative 2 times 2x squared. So that's going to be negative 4x squared. And then negative 2 times 4x. So that's going to be negative 8x. And finally, negative 2 times negative 5, which is positive 10. So now, let's combine like terms. So we have 3 terms, 6, 9. So we have a total of 9 terms before we combine like terms. So this we could bring it down. That's 2x to the 4th. And we can combine these two. 4 plus 6 is 10. So that's going to be 10x cubed. And now we need to add these three. Negative 5 plus 12, that's positive 7. 7 plus negative 4 is positive 3. So this is going to be positive 3x squared. And then negative 15 plus negative 8, that's negative 23. And so this is the answer. 2x to the 4th power plus 10x cubed plus 3x squared minus 23x plus 10. Now let's talk about factoring. What exactly is factoring? Factoring is the reverse process of what we've been doing. So we've been multiplying monomials and binomials. So factoring is the reverse of multiplication. It's basically associated with division. Now, in an earlier example, we multiplied 3x by 5x plus 8, and we got 15x squared plus 24x. Factoring will take this expression on the right and convert it to the expression on the left. So let's work on some examples. Let's say if I want to factor 8x plus 12. How can I do so? The first thing you should look for is the GCF, the greatest common factor. So what number goes into 8 and 12? 2 can go into 8 and 12, and so can 4. But 4 is greater than 2. So 4 is going to be the GCF. Now, to find out what goes on the inside, divide. 8x divided by 4 is 2x. And 12 divided by 4 is 3. And so that is factoring. Here we've converted a binomial into the product of a monomial and a binomial. Let's try another example. Factor this expression, 4x squared plus 2x. So what is the greatest common factor? Well, 2 can go into 4 and itself, so the GCF includes 2. And notice that each term contains at least one x variable. So the GCF will contain the least amount of x variables found in every term. So there's at least one x variable in each of these two terms. So the GCF will have an x variable. So now let's divide. What is 4x squared divided by 2x? If you want to write it out, you can do so here. So 4 divided by 2 is 2, and then 2 minus 1 is 1. So it's going to be 2x. And then 2x divided by itself is 1. If you write it here, these two will cancel. Anything divided by itself is always 1. And that's how we can factor this expression, by taking out the GCF, or the greatest common factor. And to check your work, to make sure that you have the right answer, you can multiply. 2x times 2x will give us 4x squared. And 2x times 1 will give us 2x. So we know this is correct. Now let's try another example. So let's say if we have 12ab squared plus 18a squared b to the third power. Go ahead and factor this expression. So what is the greatest common factor between 12 and 18? So factors of 12 and 18 are 2, 3, and 6. 2, 3, and 6, well, 12 and 18 are divisible by those numbers. But 6 is the highest of those numbers. So the GCF will contain a 6. Now here we have one a variable, here we have 2. So the GCF will contain the least amount of a variables, which will be 1. Here we have 2 b variables, and this we have 3. So the least amount is 2. So the GCF will contain 2 b variables. So now let's divide. Let's take this term and divide it by that term. So if we divide 12ab squared by 6ab squared, ab squared will cancel with ab squared, and 12 divided by 6 is 2. So we're going to have a 2 inside. Next, let's take this term and divide it by that term. So 18a squared b to the third divided by 6ab squared. 18 divided by 6 is 3. A squared divided by a to the first, 2 minus 1 is 1. So we're just going to get a. And then 3 minus 2 is 1, so we'll get b. So this is going to be 3ab. And that's how we could factor the original expression. So this is our answer. Now let's say if we're given this expression, x squared minus 25. How can we factor it? So in this case, what we have is a difference of perfect squares. When you see this, you could use this formula. A squared minus b squared can be factored to this expression. A plus b times a minus b. So a squared is represented by x squared. B squared is 25. So a is the square root of x squared, which is x. B is the square root of 25, which is 5. So our answer is x plus 5 times x minus 5. And you could check it. So just to confirm our answer, let's multiply these two binomials. So if we multiply x times x, that will give us x squared. And then x times negative 5, that's negative 5x. And then 5 times x, that's going to be positive 5x. And then 5 times negative 5 is negative 25. Now, negative 5x plus 5x adds up to 0. And 0 is nothing, so you don't have to write that. So our answer is x squared minus 25, as you can see here. So based on that, let's work on these two examples. Go ahead and factor x squared minus 9 and x squared minus 4. So the quick way to do this is to find the square root of x squared, which will be x, and the square root of 9, which will be 3. One will be positive and the other will be negative, and that's it. So for this one, the square root of x squared will still be the same, and the square root of 4 is 2. So our answer is going to be x plus 2 times x minus 2. Now let's try some harder examples. So let's factor 4x squared minus 25 and also 16x squared minus 81. So what is the square root of 4x squared? The square root of 4 is 2, and the square root of x squared is x. So we're going to get 2x. And the square root of 25 is 5. So the answer is going to be 2x plus 5 times 2x minus 5. Now what is the square root of 16x squared? The square root of 16 is 4, and the square root of x squared is x. And then the square root of 81 is 9. So the answer is going to be 4x plus 9 times 4x minus 9. Now what about this one? 25x squared minus 16y squared. Go ahead and try that one. So the square root of 25x squared is going to be 5x. And the square root of 16y squared is 4y. And then we need to have a positive sign and the negative sign. So it's 5x plus 4y times 5x minus 4y. Now here is a harder example. 81x to the 4th minus 16y to the 8th. Try that. So the square root of 81 is 9. And what is the square root of x to the 4th? So there is an invisible 2 here. It's really x to the 4th divided by 2, which is x squared. So when you take the square root of something, you're basically dividing the exponent by 2. So the square root of 81x to the 4th is 9x squared. Now what about the square root of 16y to the 8th? The square root of 16 is 4. And the square root of y to the 8th, this is the same as y to the 8th divided by 2. So it becomes y to the 4th. You just got to take half of this number. So the answer is going to be, well, this is not the final answer actually. But right now we have 9x squared plus 4y to the 4th and 9x squared minus 4y to the 4th. However, notice that in this expression, we still have a difference of perfect squares. We can factor this further. So let's rewrite the first part. Now the square root of 9x squared is 3x. And the square root of 4y to the 4th is 2y squared. And now it's fully factored. So this is the final answer. Now let's move on to the next situation. So how can we factor this polynomial? A polynomial is basically an algebraic expression with many terms. Poly means many. So how can we factor it? So we have 4 terms here. Now, notice that the ratio between the coefficients of the first 2 terms and the last 2 terms are the same. For instance, if I take negative 4 and divide it by 1, that will give me negative 4. If I take negative 12 and divide it by 3, it gives me negative 4. Whenever you see that, if you have a 4-term polynomial and you see that the first 2 coefficients has the same ratio as the last 2 coefficients, you can use a technique called factor by grouping. So in the first 2 terms, what you want to do is factor out the GCF, the greatest common factor, which is x squared. X cubed, let's do that again. X cubed divided by x squared, that's x. And then negative 4x squared divided by x squared is negative 4. Now, in the last 2 terms, do the same thing. Factor out the greatest common factor, which is going to be 3. So 3x divided by 3 is x. negative 12 divided by 3 is negative 4. Now, whenever you see these two, if they're the same, that means you're on the right track. So the next thing is to factor out x minus 4. So if we take this term and divide it by x minus 4, the x minus 4 terms will cancel, leaving behind x squared. So if you want to write it out, you could see it this way. So if you take x squared times x minus 4 and divide it by x minus 4, these will cancel, giving you x squared. And if you take this term divided by x minus 4, these will cancel, giving you 3. So basically, what you need to do is take what you see here, write it once, and then what you see on the outside, the x squared and the plus 3, put it in the second parentheses, and that will give you the answer. And so that's how you could factor by grouping. Now, let's try another problem. 2x cubed minus 6x squared plus 4x minus 12. Go ahead and try it. Factor by grouping. In the first two terms, what is the GCF? So the GCF will contain a 2. 2 can go into itself and 6. And the least of these two is x squared. So the greatest common factor will be 2x squared. Now, 2x to the third divided by 2x squared, that's going to be x. And negative 6x squared divided by 2x squared, that's negative 3. Now, let's take out the greatest common factor in the last two terms, which is going to be 4, because 4 can go into itself and 12. 4x divided by 4 is x. Negative 12 divided by 4 is negative 3. So notice that these two are the same, which is a step in the right direction. So let's write x minus 3, and whatever you see on the outside here, just put that inside the second parentheses. So that's going to be 2x squared plus 4. And that's it. This is our answer. Now, if you want to confirm it, you can FOIL. So let's do that. X times 2x squared, that's 2x cubed. And then x times 4, that's 4x, which I'll write it here. Negative 3 times 2x squared is negative 6x squared. Negative 3 times 4 is negative 12. And so that's how you could check your work. Now let's try another example. 3x cubed plus 8x squared minus 6x minus 16. Go ahead and try that one. So let's take out the GCF in the first two terms. The only thing that we could factor out really in this example is x squared. 3x cubed divided by x squared, that's going to be 3x. And then 8x squared divided by x squared is 8. Now for the last two terms, all we could take out is a negative 2. Negative 6x divided by negative 2 is positive 3x. Negative 16 divided by negative 2 is positive 8. So now we have a common factor, which is 3x plus 8. What we see on the outside, x squared minus 2, we're going to put that in here. And so this is the answer.